All right, very good afternoon there. Today we're going to have a lecture on lipids. One learning objectives that we are going to explore in depth what lipids are and the different types of lipids that are available. We understand lipids transportation in the body and its storage. Then we understand saponification, which is a process of making soap using fat, and concentrated alkalines, which is potassium hydroxide and sodium hydroxide. Then we also get to look into the disorders of lipid metabolism that I have selected out and mentioned them. And yes, let's kickstart and the lecture. One is that lipids are a diverse group of organic compounds. Organic compounds simply means those that have a carbon in them. There's the hydrogen, but majorly carbon. Something that what makes it organic is the carbon that is contained in their structures. So a lipid is a diverse group of organic compounds that are insoluble in water, but they are soluble in organic solvents. Organic solvents like ethanol are some of the examples. They are essential for life and provide a variety of functions in the body, including energy storage, insulation. Here we know that and cell signaling. We know that energy can be gotten from fats or lipids, and these lipids gives up to 9 kilocalories per gram. They also provide insulation. All your internal organs are insulated. Insulation under the skin. Think that one of internal organs should be another point that it provides some form of cushioning to your internal organs, but the insulation here is more from heat and especially the adipose tissue under the skin. And then cell signaling is also one of the functions that is performed by lipids in your body. That's why even these lipids are very important for your brain cells and everything, so because they contribute to that signaling and functioning on the brain, and more details can come about that. But first, let's continue. Lipid metabolism is a process by which lipids are broken down, synthesized, and are transported in the body. Just like you could define carbohydrate metabolism, protein metabolism, and everything. So lipids too can be broken down, or I can say digested, and then they can also be made from your body. And then they can be transported also within your body from one side to another. The transporters, the vehicles in quotations, can be the lipoproteins, which we shall look into in another lecture, or within this as well. So to begin with the types of lipids, it's supposed to be single P there if you can see. One is that we have triglycerides. The structure is right here. That this is the commonest type of lipid actually. They are made up of 3 fatty acids that are attached to one molecule of glycerols. And this is stored in your adipose tissue, and it is one of the major sources that provides energy in your body. So this is what is exactly broken down in your body for energy provision. It's broken down into its constituent with glycerol and fatty acids, and then the glycerol here can be incorporated into our Krebs cycle or the glycolytic pathway at some point, and then the fatty acids are also broken down. Then we have for phospholipids. These are found in cell membranes majorly, and they help to maintain their structures and functions. They maintain the structure and functions of the cell membrane, and they are involved in cell signal transduction too. Like I can say transport movement of signals from one point to another, and transforming them along the neurons. So these are the roles of some of these phospholipids, especially your skin tissue has that very phospholipid layer, your skin, that membrane layer has the phospholipid layer. If you study the skin into so much detail, you get to understand not maybe only the skin, but also all membranes. They really have this type of lipid called phospholipid. And we have steroids, which includes also cholesterol. These are steroids are a type of lipid with 4-ring structure, and this includes hormones, the bile acids, and the cholesterol. And right here is what I am trying to say, that they have the 4 rings. You can see the 4 rings that you have A, B, C, D, and this structure here is actually the general structure of what a steroid looks like, with its carbon being labeled, all of them. So they are up to around 30 carbons in this single structure molecule of steroid. Right here is that we have an example looking into cholesterol. It is one of the important cell membrane structure and hormone production. It is important for cell membrane structure and hormone production, but high levels of cholesterol can contribute to heart diseases. That has been talked about, I think, in this course module more frequently in the previous lecture, and we'll get to understand later on how this cholesterol here is used into atherosclerosis and also heart diseases. Now, so looking into this is a structure of cholesterol right here, and then we have also other kind of lipids which include waxes. You see the waxes that comes in your ear. In your ear, you have some form of wax, and those ones even on the skin you can have some little, but it is not pronounced or really prominent. The hair, so this protect the hair and the skin, and we have also sphingolipids, which are found in the nervous system. These are also very important for our nerve function and brain function. So what happens? Let's talk about lipid transportation right here. How are these lipids moved from one point to another? Well, after digestion, they can get absorbed, and then how do they move? How are they transported in your body? They are transported in the body in the blood, by what you call lipoproteins. Lipoproteins are a molecule that has a protein and a lipid part of it. You combine together, meaning within it is a combination of a lipid and a protein. So lipoproteins are spherical particles made up of a core of lipids surrounded by phospholipid monolayer and cholesterol. Just the way you hear it, phospholipid, it has a phospholipid layer and a cholesterol molecules. There are different types of these molecules called lipoproteins, and they play a little bit different structures, a little bit different functions, sorry. And one is that we have the chylomicron. This transport triglycerides from the intestine to the liver right after digestion of your lipids. All the triglycerides are incorporated into these molecules and transported within the body, the chylomicrons. That's the first transporter of actually these lipids in your body. Right from digestion, meaning they pick it from your intestine and they carry it straight to the liver. And then we also have another one called the very low density lipoproteins. These are really very stubborn, that they transport the triglycerides from the liver instead to other tissues. Just like you've seen, the chylomicrons take it to the liver. For very low density lipoproteins, they carry it from the liver to other tissues of your body. Can be your blood vessels, can be your membrane. Though that can be important, however, it has also a very dangerous relationship with the heart diseases. We're looking into for another type of another lipoprotein, is that we have the low density lipoprotein, the LDLs. These ones here transport the cholesterol from the liver to other tissues, just like a very low density lipoproteins. And this, in other words, in quotations, they are termed as the bad fat or the bad lipids that are in the body. You can try to Google that. You find out that along with trans fats, you will have the low density lipoproteins and the very low density lipoproteins, termed as the bad fats. Then finally we have the last type, which is high density lipoproteins, and these transport the cholesterol from other tissues back to the liver. If you understand the effect of cholesterol on the body health, like I discussed it earlier in another one of the lectures, if you understand it, you know that these high density lipoproteins are doing a great job here, that they carry this cholesterol for destruction into the liver, and also the synthesis of other molecules like the bile acids can be synthesized from this cholesterol. So it's very important these molecules is transported away from your blood rather than being deposited into your blood and forming a plaque that is going to cause you issues with hypertension and coronary heart diseases, like, and then stroke and everything. So this plays a big role, that it carries this cholesterol from the other tissues, possibly where the low density lipoproteins and the very low density lipoproteins have deposited them, and take it straight to the liver, where they can be destroyed or they can be synthesized into bile acids and bile salts. So where are these lipids stored exactly? That when you have taken in these lipids in your body, they are stored in what you call the adipose tissue. That's one of the tissues in the body. And the adipose tissue is a type of connective tissue that is made up of adipocytes. Adipocytes are cells, fat cells that are found in the body. So you can simply say fat cells instead of adipocytes, and that will really mean the same thing. You won't really deviate from saying the same thing. Adipocytes here store triglycerides in the cytoplasm. So after digestion, all these triglycerides you have that are transported, they are taken into the adipocytes or the fat cells, and then they store them in their cytoplasm. And when the body needs energy, these triglycerides can now be broken down to release an energy into the bloodstream, which I think in one of the lectures must have been discussed earlier. Let's dive into the process of saponification. And let's get to understand what is saponification. This is the process of making soap by reacting a fat or oil with a strong base, such as sodium hydroxide or potassium hydroxide. Strong bases here, like the sodium hydroxide and potassium hydroxide here, have a certain form of reaction that they react with our lipids, and then they produce for us the soap. Which you can really have them here is that you have triglycerides. If you react them with potassium hydroxide, which is one of the strong base, you realize that there's a release of our triglyceride molecules, and then the fatty acid molecules are the ones that are attached to potassium, and they form our salt. Our soap. Yeah, so that's basically the reaction. This is a general reaction that produces glycerol and a soap. The glycerol molecules and the soap. So this is very important to understand this overall reaction. So after forming this reaction, after reacting our fat or triglycerides together with potassium hydroxide or the sodium hydroxide, there is what you call salting out. You find out that this thing has reacted, but then you need to separate it out from the other components of the mixture, so that you only have a soap that you can now press into shapes that you want. So one here is that you add sodium chloride, sodium chloride. This is our normal salt here. I don't know how many people have, if there are people who have made liquid soap earlier, and that's if you study that process, it describes exactly what it is. That in that we have sodium chloride of a given quantity that is added also into the mixture, so that it helps in salting it out. Meaning what happens here is that the sodium chloride here will increase the ionic strength of the solution, meaning this will disrupt some interaction between soap molecules and water, meaning the soap will separate itself away from water. So this forces the soap molecules to aggregate and separate from the water, like I said, and then they form they form something like foam, which is a cardimas, and then you can press it into the shapes you want. That's why we have long bars of soaps. We have very short, very small bars of soap, the one for showering, maybe at home, or family soaps. We also have these very tiny ones that hotels use, They are just tiny and tiny. I think it is a single use. They put it there every day. Every hotel, restaurant, or lodge, I think, let me say lodge and hotels, inns, all those guest houses have them. That you just use it and you can leave it there. And once you've used it, there is no loss not picking them back because they are made in a smaller shape, a smaller size that one person can use it and then utilize it to the maximum. And then the soap molecules are amphiphilic, meaning they have both the hydrophilic head and then the hydrophobic tail. A brief understanding of some terminologies which are hydrophilic, meaning it is water loving. This simply gives you an understanding that this side of the soap molecule here called the hydrophilic head can dissolve in water, meaning they love water. So they get to interact with water and dissolve in that. However, there's what you call the hydrophobic tails, which is water hating. They hate water a lot like some people do. Or some people hate water. So what happens is that it repels and it repels away from water. So much as you try to put it in water, there is no reaction and it will repel itself from water. So it doesn't really dissolve but repels itself. And this allows soap to emulsify dirt and oil, meaning everything that when you're washing, every dirt will get dissolved and then it will also be bound to the foam that is been formed by the soap, and it can now be washed out. So this makes washing clothes wow, a very easy thing with water. So you can wash the dirt away with water so easily. Let's get to understand now some of these disorders. Let's get to understand disorders of lipid metabolism. Lipid metabolism disorders here can arise from various factors, which includes one is that inherited genetic mutations. Second is acquired factors like lifestyles and diets. How do you feed yourself? How do you live? Do you do some exercise? Are you a smoker? Are you a drunkard? And all that kind of thing of a lifestyle. Yeah, what kind of food choices do you really make? So everything, such metabolism can develop from that. Lipid metabolism can develop from acquired factors like lifestyle and diets. You were not born with them, but then in your life, in the course of your life, you tend to develop them because of your lifestyle, how you live your life, how you make your choices of the food and the lifestyle. Yeah, everything. Unlike for inherited genetic disease, you inherit them from your parents. That's exactly it. You inherit them from your parents and then you just continue with them. However, it's advantageous. Some of them can be recessive, but then you still really need to take caution about everything. Some of those metabolism, the genetic mutations. So let's look at this. Next is that it disrupts the body's ability to properly process and utilize lipids. So the body will not be able to utilize the lipids because seriously that it is a disorder that has affected maybe an enzyme, maybe a process in the breakdown or in the metabolism of lipids, and so it will be very hard to get to utilize the lipids. So the process of lipid metabolism may not occur as efficiently as expected, or it would be without that condition or disorder. And utilization can also be reduced or affected unless the person have decided to pick up a border and everything. And sorry, unless the person have disrupt the body's ability to properly process and utilize lipids, unless there is really a mechanism that is known or someone has really taken a way forward to do this. So it can lead to an accumulation of harmful lipids in your tissues and organs, which we have talked about earlier, or the so-called bad cholesterol. We have the cholesterol, so let me say generally low density, high density, accumulation of trans fat and everything. So all these, when they accumulate around your tissues and in organs, they can cause you a very significant health problem. And one is one of these lipid metabolism disorders is the hyperlipidemia, where one has a high levels of cholesterol and triglycerides in your body. We have hypercholesterolemia. This word hyper here just means higher. Lipidemia meaning you have a lot of those lipids, which are the cholesterols and triglycerides in your body. Then hypercholesterolemia, you can just relate this that it is, but this is an inherited disorder that leads to the low density lipoproteins, meaning you inherit this disease in a way that the whole of your body, it tends to have a high levels of what, low density lipoproteins or cholesterol at all times. Then we have dyslipidemia, which is a condition. This is a condition in which the blood has an abnormal level of lipoproteins. You have a substantial amount of lipoproteins in your body that are higher beyond the normal levels. And then we have other inherited disorders, which include the Gaucher disease, the Niemann-Pick disease, the Fabry disease, and among others. Chylomicronemia syndrome, this one is difficulty absorbing dietary fats, and this comes straight from the lipoprotein or the molecule that transport lipids called chylomicrons. So if you have a syndrome, a factor that this factor is the one that affects chylomicron, meaning we may not truly be able to absorb our dietary fat much as we take them and it gets digested. How are you then going to use it in your body since it's not going to be utilized by your body efficiently? We have the cytosterolemia, which is the accumulation of plant sterols. In one of these lectures, we'll look at those the plant sources of lipids or sterols. Yeah. So there are symptoms of lipid metabolism disorders. That the symptoms of lipid metabolism disorders can vary depending on the disorder and its severity. What disorder do you have and how severe is it? So that will be able to find out. That will be able to determine the kind of symptom you have. And one is the fatigue. We have muscle pain, joint pain, enlargement of organs like the liver and the spleen. That these organs can get enlarged once they are being stressed up, or there is a lot of things for them to do really work on in the body. We have neurological symptoms such as seizures, then developmental delays, and then skin changes, xanthomas, and rashes. And then we have digestive problems and cardiovascular diseases or cardiovascular issues. So those are some of the symptoms of these disorders. How do you diagnose this? Is that you first have to take a family history. Who in your family, given the fact that some of these disorders are genetical, you ask if they have had a case of such a kind, who is having such a condition that they are managing. And then you look into physical examinations, you examine physically, and this is well done by the clinician rather than a nutritionist, but if you're sharp enough, you can understand this as well. And then we say blood test to measure lipid levels, or what you call the lipid profiling. Yeah, I think that's it. Then we have genetic testing for specific diseases. You go and test someone's genetics, and you say genetically he's having such a condition, or he's not. So that is basically what we call the test for genetic test for specific disorder. Imaging test like computed tomography, scans or magnetic resonance imaging, which is the MRI. Well, this will help to detect the buildup of cholesterol and other fats. You can do that on your body, and if you check on results and realize that it's going up, you should be able to reach to the nearest health facility to get help. Or you as a nutritionist, you can now find a solution for this person because you possibly have studied so these diagnostic methods can be best used in combinations. Take a look at the family history. You take family history, you do some blood test, you can take physical examination, and also it gives you a clue of what lab request do you have to request for. All the above mentioned methods cannot be used on one person in one or interchangeable, something of that kind. So, and finally, thank you very much. We have come to the end of this lecture of ours about lipids, and see you in the next lecture. Thank you.